So case 3. Case 3 is k is equal to 0. Case 3 is k is 0. So that means we are going to get it as m square minus 0 is equal to 0. So m is equal to two solutions 0, 0. This is for x. And for t, what happens? M square again minus 0 equal to 0 because k we are taking as 0. Here k is 0. M is 0, 0. So now, how can you write? This thing as the same roots, same real roots, right? Equal roots. So the solution is x is equal to c1 plus x, not c1. We already use c1, c2, c3, c4, c1, c2, c3, c4, c5, c6, c7, c8, c9. This is c9 x, c10 e raised to 0x, and our t is equal to c11 plus this is the solution for x. The other one is for t. So t c12 e raised to 0t. E raised to 0t. So the answer will be x is equal to c9 plus x c10 and t is equal to c11. This is 1. c11 plus c12 t. T c12. c11. Or you can write t here also. Don't worry. T c11 plus c12 will work. cx9 plus c10. That's also right. So what is u? U is equal to xt. So c9 plus xc10 into c11 plus tc12. This is the answer. So 3 cases we already find. Okay. And you have to find which one is the suitable solution. Okay. Which one is the suitable solution. So let me write the 3 solutions we already got here. First one is u is equal to which one? C1 e raised to px plus c2 e raised to minus px into c3 e raised to cpt plus c4 e raised to minus cpt. This is the first one we got. Next one is c5 cos px plus c6 sin px into, we don't want this anymore. So c7 cos cpt plus c8 sin cpt. This is the second one. And the third one is u is equal to c9 plus xc10 into c11 plus tc12. So in these 3 you have to find the suitable solution. Okay, suitable solution means we are dealing with the wave equation, that is vibrations. Anyway, this vibrations equation it must contain the trigonometric functions. It must contain that, we can write it like that. It's in your textbook. So it must contain the trigonometric function. So the suitable solution will be this one. It must contain the suitable the trigonometric function. So the suitable solution is this. That you have to write for that is your final step. Okay, I hope all of you understand this one. Now we will move on to the problem. This is how we are finding the solution for wave equation, heat equation and Laplace equation. Everything is the same method. All 3 are very, very important. Derivation is important. Laplace, there is no derivation. But the solution of Laplace equation is there. So what you have to remember is you have to remember what is wave equation, what is heat equation, what is Laplace equation. Once you got that, you have to use the same method and you are taking the 3 cases and you are just writing the suitable solution. Is like that. Okay, so this is very important. The solution of finding this one wave, heat and Laplace. Laplace, there is no derivation. Only the solution of Laplace equation, that is very important. So this is how we are finding the solution. Okay. Now we are moving to a problem. You already have that problem with you, otherwise I have to write the whole thing here. It's like a lengthy problem. A string is stretched and fastened. You can, if you have your notebook, you can just take it and read the problem. A string is stretched and fastened to two ends L apart. Motion is started by displacing the string in the form y is equal to a sine pi x by L, sine pi x by L, from which it is released at time t is equal to 0, released at time t is equal to 0, show that the displacement of any point at a distance x from one end at time t is given by yxt is equal to a sin pi x by L cos pi ct by L. That is in a PDF thingy, the first problem. If you have it, you can just look through that. Okay, so I'm going to, in all these questions, the method is you have to find the initial condition, and it can contain, it must contain boundary condition also. First, you can write the boundary condition. Boundary conditions means at the end. 0 to L means beginning and the end. Boundary condition. Boundary condition will be there and initial condition will be there. Initial condition will be there. And here, reading the problem, we can see that the string is stretched like this. Like this. So right now, this is the position of the string. And they are saying it is released. It is released. That means we are starting from this position. The string is like this now. The string is like this now. Okay. So, I'm going to write the boundary condition and initial condition. So, boundary condition means y x equal to 0, the distance x equal to 0, y 0 t. That will give you one initial condition. Okay. And the other one is this boundary condition. Sorry, boundary condition. And this one is, this is our 0, this is our n. Okay, so y, l, t. These are called as the boundary conditions. This is x equal to 0, that is the boundary, l, t. So these two are the boundary conditions. Okay. Now, reading this problem, we can see that y 0 t, at that is x is equal to 0, the displacement is 0. Y is equal to 0. Okay. And YLT also, displacement is equal to 0. Okay. So you already got the boundary condition. Now, the initial condition. Initial condition, they are given. Look at this. Motion is started by displacing the string in the form y is equal to a sin pi x by L. Y is equal to a sin pi x by L. So what is here? Now this is the position. This is the position and the displacement is given as a sin pi x by L. So that is one initial condition. So at time t equal to 0, the displacement, that is y x 0. So these two are the boundary. Y x 0, that is our initial condition. Initially this is in this position. At time t 0, what is the displacement? They are given as a sin pi x by L. A sin pi x by L. Okay. Now one more thing is there. What is the velocity at this position? The velocity, that means dy by dt. At t equal to 0, the velocity will be 0 because it is in this position. So there is no change in the velocity at any time t. Or so you can take this as dy by dt. At t equal to 0 also, this is equal to 0. So the velocity, that is dy by dt, t equal to 0, at time t 0, dy by dt, the velocity at this position is 0. Okay, so this is how we have to figure out all these boundary condition and initial condition. The displacement here is 0. So usually it is coming in this format. Boundary condition will be as from starting till end. So these are the boundary. Initial condition means one will be yx 0 and you have to find the velocity there. Maybe they are given in the question, or you can while reading the question you will get it. So here you can get it from the question. Dy by dt, the at t equal to 0 will be 0 because the velocity is 0 here. This is the starting position. And this one they are given in the problem. The displacement, that is yx at time t equal to 0, the displacement will be a sine pi x square. Once you got this one, that will be very easier to find out the rest of the problem. Okay, so we will do the problem. These are the conditions we are going to use here. Okay, so let me write it here. You can see here, right? Y0t is equal to, so that those are the boundary conditions. Y0t equal to 0. YLT is equal to 0. Boundary. And initial condition. Initial condition is yx0. Yx0 is equal to a sine phi x by L. And we have this dy by dt, dou y by dou t. We are taking the partial differentiative, dou y, or not the ordinary dou y. We are dealing with the partial, dou y by dou t at t equal to 0. This is equal to 0. So these are important. Once you got that, you can start doing the problem. So you have to read the question thoroughly. You will get all the clues from some are given some will be given in the problem, and some will be you have to find out from the problem. Okay. What happened here? Can you see that one? X by A. Okay. So we are starting the problem. So what is the wave equation? You know what is the wave equation? You have to by heart it. Wave equation is dou square y by dou t square. Okay, my equal to c square dou square y by dou x square. This is the wave equation, and we already know that the solution for wave equation. What is the solution for wave equation? Solution for wave equation is y xt is equal to yxt is equal to. I wrote it like u, right? That's wrong. You have to use this y itself. Got it? I think I wrote it like u in that solution part. Am I right, Amalda? Anybody here?
Yes, ma'am, you wrote it as U.
U. I'm sorry, that is y. Okay. So you have to be corrected. That is y. So y is equal to C1 cos px. So we already know this one as C1 cos px plus C2. So we already know the solution is this one. Px into C3 cos pt plus C4 sin pt. C for sin pt. Sin cpt. Here sin cpt. Cos cpt. Sin cpt. Okay. So this is our, we can wrote this as first, this is okay. We can write all these as first equation, second equation. So y0t, we already have that. I'm marking this as first equation, y0t. This one as first equation. This as first equation. This is second. This is third. This is fourth. This is fifth. Okay, mark like this. Then it will be easier. Now you have to find the values of C1, C2, C3, C4 first. Okay. So what we are going to do is we are going to start from y0t, initial condition. Okay. So using that initial condition, that is using y0t, and this is equal to 0. So what I'm going to do is I'm going to make x is equal to 0, putting in the solution, you will get it as y0t is equal to, this is equal to 0. X is equal to 0. Here x is equal to 0. So that will give you C1 plus C2 sin px. So, C1 plus C2 is 0 because we are giving 0 to x. Sin 0, 0. This is 1. C1 into C3 cos CPT plus C4 sin CPT. C4 sin CPT. And C4 sin CPT, this is equal to 0. Because we are using this initial condition, boundary condition here. We are using this boundary condition here. Okay. Now we got like this. Now what is the conclusion we can get it from this one? Here we can say that C1 equal to 0. If you do this is equal to 0, if you take this is equal to 0, what will happen? This yxt becomes a trivial solution. Yxt equal to 0. If you take the whole thing as 0, what will happen? Yxt is equal to 0. So that is a trivial solution. Equal to 0 means there is no meaning in that. That is why we are taking C1 equal to 0. So from this one, what we are getting? We are getting the constant. Therefore, C1 equal to 0, and this cannot be equal to 0 because this yxt becomes a trivial solution. Yxt equal to 0 means meaningless. Now our solution one becomes, now what you got C1 equal to 0. C1 equal to 0. Now we are going back to this one and we are again going to write yxt. Yxt is equal to C1 is 0. Then you are getting the remaining is sin px into C3 cos CPT plus C4 sin CPT. So this is how we are doing. Once you got a constant, once you got the value of a constant, you are going back to yxt and giving the value for that constant, and we are writing the new yxt. That is very important. New yxt. So C1 equal to, once you got the constant, the value of a constant, you have to go back to yxt and write the new solution. So this is our new solution now, yxt. Yxt, that is our new solution. Now we are going to use the next equation, the next condition. Okay. So that is, here we are using dy by dt, the velocity dy by dt is equal to 0. Okay. Now using phi, we are going to use phi, that is dou y by dou t is equal to 0 at t equal to 0. In order to do that, we have to find dy by dt, dou y by dou t, dou y by dou t. Can you see the bottom part? So dou y by dou t, can you see the bottom?
Yes, ma'am.
Okay. Now, dou y by dou t, what is dou y by dou t? You have to find, we are differentiating with respect to t. So that is, this is a constant. Treat this as a constant. C2 sin px, differentiating with respect to t. So this becomes minus C3 sin CPT into CP plus C4 cos CPT into CP. Okay. And we know at t this is equal to 0, at t equal to 0. So we are going to use that. So this is dou y by dou t. So we are going to take dou y by dou t. So this is our new one. Let me erase this part because we don't need that. So dou y by dou t at t equal to 0. This is equal to 0, we know that. So I'm going to take at t equal to 0. So this is equal to C2 sin px into t equal to 0. T equal to 0 means this one, sin 0, 0. C4 sin CPT, t equal to 0 means this becomes 1. So we will get it as at t equal to 0. C4 sin px, C4 cos CPT into CP, this is equal to 0. No, this one is PT at t equal to 0, right? So this is 1. C4 CP. C4 at t equal to 0. CP equal to 0. Okay. Now in this one, C2 cannot be 0. If C2 equal to 0 means what happened to this YHT? The whole thing becomes 0, and YHT equal to 0 means that is not a trivial solution. Right? Not a trivial solution. So the only possibility, and sin px equal to 0 means again the same thing will happen. This becomes 0, and that is a trivial solution. It cannot happen. The only possibility is C4 equal to 0. Okay, the only possibility is C4 equal to 0. So, therefore, we can write C4 equal to 0. Like this, you have to find each constant value and you have to rewrite this YHT. Now, once you got the C4, I'm going to rewrite the YHT. So, YHT is equal to, how can you write that? C4 is 0 means you will get it as C2, C3, sin px, cos CPT. This is our YHT. So this one you can write this as 6th equation. This is 6th. This is 7th. Mark each one. Okay. This is 7th. Now which is our new YHT? This one is our new YHT. So once you are getting the values of each constant, you have to rewrite that. Okay. So now our YHT is equal to C2, C3, sin px, cos CPT. Okay. Now we are going to use the other condition. Next condition. So next condition is using the boundary condition YLT equal to 0. Using the boundary condition YLT is equal to 0. YLT is equal to 0. So x is equal to L. So I'm going to write that YLT equal to 0 means YLT is equal to C2, C3, x is L, sin P L cos CPT equal to YLT is 0. We already know that. So this is equal to 0. This is equal to 0. Okay. Now, here, where is our 7th one? This is our new YHT here. Okay. If C2 equal to 0, what happens? This is equal to 0. Again, it becomes a trivial solution, meaningless. If C3 equal to 0, the same thing will happen here. So, C2, C3 cannot be 0. C2 not equal to 0. C3 not equal to 0. The only possibility is sin PL is equal to 0. Okay. Therefore, sin PL is equal to 0 means PL is equal to n pi and LP is equal to n pi by L. N pi by L. Okay. Now, once you got the value of P, you can substitute here and that will give you new YHT. Okay. So, I'm going to substitute that here. Therefore, YHT is equal to yxt is equal to C2 C3 sin n pi p is n pi x, we have an x here, n pi x by L cos, again p is here, so c n pi by L t, n pi by L t. Okay, so now this is our new yxt. So put that as eighth equation. Eighth equation. Now what is the next step? You have to use one more. We have one more initial condition, right? That is our yx0. So what we are going to do is you have to find out the value of C2 and C3. That is what we are trying to do. C2 and C3. Okay. From this one, these two, we have to find out the value of C2 and C3. Okay. So for that, what we have to do? We have to equate here t equal to 0. The eighth equation. Now, putting t equal to 0, what happens? Yx0, this is equal to C2 C3 sin n pi x by L, and putting t equal to 0, that is cos 0 1. Okay. Now this is our yx0. We got it right now, and they are given the condition as initial condition yx0 is equal to a sin pi x by L. Okay, a sin pi x by L. So what is we are going to compare that. So here we are getting C2 C3. Comparing this with fourth equation, you will get it as C2 C3 is equal to A, and the answer is, so C2 C3 is equal to A. So the solution yxt is equal to yxt is equal to, that is A sin n pi x by L, A sin n is 1. N is because comparing this one, sin n pi x by L and sin pi x by L. Let me compare here. This is equal to A into sin pi x by L. So what is our C2 C3? C2 C3 is equal to A and n is equal to 1. Comparing those two. So you can write the yxt is equal to, how can you write that? A sin pi x by L, A sin pi x by L. We have an n here, that is 1. We have an n here, that is 1. So this is our final yxt. So we are substituting the value for C2, C3 and n here with comparing with this initial condition. So you will get it as cos C pi t by L. This is the answer. So in all the problems, this is the method. For all the problems, this is the method. They are given the boundary condition. Sometimes you have to find out this f of x. Actually, we are considering this as f of x. So this f of x, in some questions you have to find out. Okay, in some questions there will be given it, that will be given in the problem. And some conditions we have to find out from the question by reading the question. After getting this, you have to start from the equation, which is if it is heat equation, start from that. If it is wave question, start from wave equation. For wave equation, we already know that the solution is. You can write that. The solution is, you already have that. So after writing the solution, you have to eliminate each constant using each conditions, that is boundary or initial condition. And once you got this once you got the value of each constant, you have to rewrite this yxt. Once you got a value of a constant, you have to rewrite that yxt, then you will get a new equation as yxt, and that procedure you have to follow till you used all these conditions, and that will give you the final answer. Okay. So this is the method you have to use, and I will show you one more problem. There we are using the Fourier series also. In between there is another one that you can that is in your notebook. You can refer that. Let me do one more problem. That is the third problem in your notebook. So third problem, let me read that problem. The points of trisection of a string are pulled aside through the same distance on opposite sides of the position of equilibrium, and the string is released from rest. Derive an expression for the displacement of the string at subsequent time and show that the midpoint of the string always remains at rest. Okay. So the points of trisection of a string are pulled aside through the same distance. So let me draw the figure. So it is pulled aside through the same distance in opposite direction. That means like this. So this distance is equal. These two distances are equal. Okay. And it is pulled in the opposite direction to equal distance. And derive an expression. So points of trisection means this point you can take it as L by 3. Distance L by 3. And we are taking the Y part as A. I already gave you in the notebook all the derivation and all these explanation and all. So this one is L by 3. This is O, A. So this is 2L by 3. A, okay, and this L means A means, can you give me the coordinates for this A? This one. Give me the coordinate for A. Can you give me the coordinate for A? Points of trisection means this is L by 3, 2L by 3. The next one is this A will be 3L by 3. So this is L 0. This is 0, 0. Okay. This is A. L 0. Okay, so this is what it means. L by 3, a point of trisection. L by 3, 2L by 3, 3L by 3. That is L 0. Okay. So now here, what we have to do is you have to find out the initial condition and boundary condition first. Okay, so I'm given in your notebook, let B and C, this one, B and C. Let B and C be points of trisection, and the string, the length of the string OA is equal to L. Okay. Initially, the string is held from this one, 0 B dash. This is C dash. Initially, the string held in O B dash C dash A. This is the position of the string initially. So initially, the string is in this position, O B dash C dash A. Okay. Where B dash and C dash is equal to A. B dash and C dash is equal to A. This is A and this one is A. Okay. Now you have to find the boundary condition and the initial condition. So what is Y? The displacement at the beginning, Y0t, this is equal to 0. And here, displacement, that is YLT, this is equal to 0. Okay, the displacement is 0. So you got two conditions, make this as 2 and 3. The other one is our solution part. What is the solution for wave equation? That is Y is equal to C1 cos Px plus C2 sin Px into C3 cos CPT plus C4 sin CPT. This is our solution. Mark this as 1. Oh, mark this as 1. Okay. Now you have to talk about the initial condition. At t equal to 0, can you say anything about the initial velocity? The initial velocity in this condition at t equal to 0 will be 0 because this is the initial position. So dy dou y by dou t at t equal to 0, this is equal to 0. Is equal to 0. So these are the conditions that we can already find from this one. Now you have to find that y x 0, that is our f of x. That is our f of x. So y x 0, the displacement, you have to find out. That means we are going to find at each position that OB dash, BC dash, and C dash A. Like 3 parts we are going to do that. How can you find the equation of this line? That will give you the y of x0 at this position. Okay, so how can you find the OB dash, the length of OB dash, the displacement OB dash? We can use these points and we can use the formula that is y minus y1 is equal to m into x minus x1. That will give you one part. For the second part, again you have to use these 2 points and you can use this formula that will give you the second part. Okay, so let me show you one part and the other one you can do. So you have to find yx0. So yx0, that means the first part is OB dash. OB dash. For OB dash, that is the length of OB dash. OB dash y minus y1, that is y minus 0, m into, what is the equation, the formula for finding the slope? Y2 minus y1 divided by x2 minus x1. So we are taking this as x1 y1, x2 y2, x2 y2. So that will be equal to y minus y1 is equal to m. M is y2. Y2, that is a minus 0 divided by x2 minus x1, that is L by 3 minus 0. So that will give you 3a by L. Slope is 3a by L. So slope is 3a by L and x minus x1, that is x. So our first one is y is equal to 3a by L minus y2 minus y1 equal to m into x, right? Into x. And this is between 0. We can write this as 0 less than x less than or equal to L by 3. So that is the displacement, the first part. This is our first part. Okay. Now you have to find the same thing here, b dash b. That is the second part, b dash c dash. B dash c dash, equation of b dash c dash, that is our next part. And that is, I will give you the same formula, same format. You can find the equation. This is like L minus 2x. And this is between L by 3, less than or equal to x, less than or equal to 2L by 3. Okay. And the third part, you have to find C dash A. C dash A. C dash A. And that is, C dash A is again y minus y1 equal to m into x minus x1. M is y2 minus y1 divided by x2 minus x1. And that the answer is 3a by L into x minus L. And this is between 2L by 3 less than or equal to x less than or equal to L. So this is our yx0. So see, in this part, in this problem, you have to find out that from the given information. They are not given in that problem. So in this way, you have to find out. Okay. So after getting all these initial values, we can start from the all the comparing with these initial conditions. You can start eliminating each constants like C1, C2, C3, C4. Once you got the value of one constant, rewrite this y. That is very important. Okay. So here what is going to happen is once you use that y0, yt and everything, I will give you the final answer as, because it's too lengthy. Let me give you the final answer and I'll show you where you are going to use the Fourier series. So these are the conditions. Let me erase this one. So from where you have to start? Using equation 2 in 1. Using equation 2 in 1, you will get it as C1 equal to 0 as earlier, and you will get new thingy, that is y. I'm not going to do in deep, just giving a hint, just steps and all. Okay. So this is the thingy you are getting for CPT. The same steps we use for the other one, sin CPT. Now this is our new yxt. This is our new yxt. Now once you got that, use 3 in 6, that is ylt is equal to use ylt is equal to 0, and that will give you p is equal to n pi by l, that will give you this one. Then our new yxt. Always once you got the value of these, you have to rewrite yxt. That is very important. So yxt is equal to c2 sin n pi x by l into c3 cos c n pi t by l plus c4 sin c n pi t by l. Okay. Now once you got that, so this is our new yxt here. After getting p, I had one there. Okay. Now yxt is done. Now using 4 and 6, that is dou u. This one, dou y by dou t at t equal to 0. At t equal to 0, that will gives you c4 equal to 0. C4 equal to 0. Dou y by dou t. How can you find this dou y by dou t? You have to differentiate this one. Dou y by dou t. This is our new yxt. So differentiate this one, and then at t equal to 0. Differentiate this one and put at t equal to 0. At t equal to 0, you will get it like this. At t equal to 0, you will get it like sin n. Everything is in our notebook, okay? And you can refer that. I think I made a small steps. I skipped it, but it's fine. You can understand. So see to this one. Okay, from this one, look at the possibility, which can be 0, which cannot be 0, like that. And from here, you will get it as the only possibility is C4 equal to 0. The only possibility is C4 equal to 0. Now, once you got this one, you have to rewrite the yxt. Rewrite, you will get a new one. So that is yxt is again, we are rewriting it as C2 sin n pi x by L, and the remaining is C3 cos Cn pi t by L. C4 is 0. Okay. So this is our new yxt here. New yxt. Okay. Now this is not enough. So I'm going to put this C2, C3, that is equal to Bn. Okay, that is equal to Bn. Let me erase these. So this is our final thing after using 3 boundary and initial equation. Still we need to use this one. Yx0 we didn't use yet. So we are going to use that in order to find the value C2 and C3. Okay. So yxt is C2 in this part you got. After getting this one, I am going to write this C2, C3 as Bn. Okay. So that is where we can write it as yxt is equal to all together we can write this as C2, C3, and we are taking sigma n equal to 1 to infinity. C2, C3 is equal to Bn. So I am going to put it like this: Bn sin n pi x by L cos n cos Cn pi t by L. Okay. So as a general solution, you can write like this. So you can write as adding all solution of this one, as a general solution, you can write this. Okay, you can write that. Now here we are going to use this condition yx0, because we already have this yx0 here, right? OB dash. There is one more there. OB, the first one is 3a by L x 0 less than or equal to x less than or equal to L by 3. So we already have this condition here. In order to compare or find the values of Bn, we are going to do here also yx0. At t equal to 0, what happens? Sigma n equal to 1 to infinity Bn sin Bn, let me write that. Bn sin n by x by sin n by x by n, because our t is 0, cos 0 is 1. Okay, so that's it. Now this must be equal. Ux0 and ux0, this must be equal. So our aim is to find the values of bn's. So we are, once you got y of xt, in order to compare this, we are putting like yx0 in our general solution, and getting like this. So this must be equal to this yx0, this one and this one. So here in order to find this bn, what we are going to do is, so we are going to find this bn using this f of x. Since this is equal to this, using this f of x, we are going to find bn using the Fourier half range, using Fourier half range sine series, because we have sine here, sine series. If it is cos, you have to use the cos series. So can you tell me what is the formula for that sine series and all? Do you have any idea? Bn is equal to 2 by L integral 0 to L f of x sine n pi x by L dx. This is the half range. You cannot see that. Let me erase all this because we don't need that. What is the formula for a half range? Fourier half range sine series. Bn is equal to 2 by L integral 0 to L f of x sine n pi x by L dx. This is the formula for sine series, half range sine series. So we are going to use this in order to find Bn, and we are going to use this f of x here. So we will get 3 parts for this section. So that is Bn is equal to, what we have to do? Bn is equal to let me write it here because it's a lengthy one. So Bn is equal to 2 by L. We have 3 parts. So first one is from 0 to L by 3. 0 to L by 3. What is our f of x? F of x is 3a by L x sine n pi x by L dx. Okay, plus next is 2 by L is common. Next is L by 3 to 2L by 3. 2L by 3 f of x. What is our f of x? 3 by L. 3 by L, L minus 2x into sine n pi x by L. N pi x by L. And one more is there. That is this one. So integral 2L by 3 to L. And this is our f of x. 3a by L into x minus L into sine n pi x by L. So this part we have to find out Bn. Okay. So after getting that answer, you can write the final answer. That will be a lengthy one. Practice, you will get it. Okay. Maybe they can ask that also. So finally, after solving all this, I'm not going to do the integration part. It will take some time. So let me erase this one, and you will get the final answer as Bn is equal to 18a divided by n square pi square. 1 plus minus 1. I have all the steps I gave you in your notebook. You can go through that. Okay. Every step is in your notebook. In that in that PDF thingy that I gave you. This is the final answer we are getting. N is equal to 0, 1, 2, 3, etc. So we are getting Bn. We want to find each this one. So Bn is equal to 0 when n is odd. Bn is equal to 0. When n is odd, this becomes 0. So Bn is equal to 0 when n is odd. Okay, so B2, you can find the value of B2 putting n is equal to, this is 18a. Putting n is equal to 2. You will get the answer B2. And B3 is 0. B4 you can find, etc. And you can write the final answer yxt is equal to. So you will get the final answer as yxt is equal to. So after getting B2, B3, all ones will be 0. B2, B3, B2, B4, B6, everything you will get it. And after that, your yxt will be like this. 9a by pi square sigma m equal to 1 to infinity 1 by m square sine 2m pi by 3 sine 2m pi x by L, then cos 2m pi ct by L. Like this you will get. Okay. So you have to find one more thing. When x is equal to L by 2, in the middle point, you have to show that the string is always at rest. That means you have to show that this is equal to 0 at x is equal to L by 2. At x is equal to L by 2, you have to show that this yxt equal to 0. Then we can say that the string is remains in rest. The string is in the resting position. Okay, so when L by 2, after putting L by 2 for x, you will what you got? X is equal to L by 2. Where is L by 2? L by 2. Here we are going to put L by 2. L by 2 means that becomes sine m pi, and this is equal to 0. This will be equal to 0. Once this is equal to 0, everything will be equal to 0. So this is equal to 0. Okay, that means the middle point, the middle part at x is equal to L by 2, the string is in the resting position. This becomes 0. Putting x is equal to L by 2. So that is the method you have to follow. I hope you understand the method how to do the equation problems. There is one more in between. You can go through that. This is how we are using the Fourier series method in between the problem. Okay, so let me go to real numbers. You have to be you have to start learn by heart. That's important also. Real numbers is important. You have to go through that and you have to study the derivation. What is real numbers equation and the derivation. Now we are moving to the heat equation. Heat equation. The derivation is important. Derivation is important. I'm not going through the derivation. Now the solution of heat equation. Solution of heat equation. Solution of heat equation is also the same. Solution of heat equation. So the derivation you have to find, learn by heart, and you have to remember what is heat equation. Heat equation is, what is the formula for that? Dou U by dou T is equal to C square dou square u by dou x square. This is the heat equation. You have to remember that. And the derivation. Now we are going to find the solution of heat equation. Okay. So solution of heat equation means use the same procedure what we did for the wave equation. Same thing. C square dou square u by dou x square. Now here this is u and the wave equation we took it as y equal to xt. Here they are given u. So from where you have to start? U equal to, and u is a function of x and t. So xt. Function of u equal to xt. Okay, now you have to find dou u by dou t and dou square u by dou x square. What is dou u by dou t? Is equal to xt dash. Same method. What is dou u by dou x? This is equal to x dash t. But we need this one. Dou square u by dou x square. This is equal to x double dash t. So we are going to substitute these ones. So this becomes xt dash is equal to c square x double dash t. Now what is the next step? We have to bring the same variables to each side. So that will be equal to x double dash by x. This is equal to t dash by t into, I'm going to take this as 1 by c square because that is the format given in the textbook. So once you got this one, you have to equate this to k, right? Then you can write x double dash minus k x is equal to 0. That is one equation. The other one is t double dash minus c k t is equal to 0. So that's the same procedure. Do I need to explain the whole thing or you are fine with that?
Understood, ma'am. This is fine.
That's fine?
Yes.
Okay. So we will move to the problem. So after this one, you have to find the m square, the auxiliary equation, and you have to take 3 cases. And k is positive and p square. K equal to p square. Okay. One k. First case, k is negative and minus p square, k is 0. So you have to do all these cases and write the solution. And the solution is this one. It is given in the textbook. The suitable solution is like C1 cos px like that. So that's it. Now we are moving to the problem side. So here one problem they are giving. I'm just doing the go through the grammar textbook also. Okay, so there are the workout problems. You can check that. Don't worry, they are not going to ask from some other textbook. Nothing. It can come from the grammar textbook, notebook. So one problem I gave you in the notebook is a bar 100 centimeter long with insulated sides, has its ends kept at 0 degree, 100 centimeter long. 100 centimeter long, and ends kept at 0 degree centigrade and 100 degree centigrade. 100 degree centigrade, and it says steady condition until the steady state condition. So initially it has the steady state condition. It has steady state condition. Steady state condition. Okay. Steady state condition, and 2 ends are then suddenly insulated and kept. So find the temperature distribution. So we want to find the initial condition, boundary condition, right? So before that, let me tell you one thing. We have the heat equation. Heat equation is what is our heat equation? Heat equation is rho square y by dou u by dou t. This is equal to c square dou square u by dou x square. Be thorough with this one. Steady state condition. For steady state condition, for this is important. Steady state condition. Steady state condition. Heat equation is. You must remember this one also. Dou square u by dou x square is equal to 0. Okay, so for steady state condition, heat equation will be dou square u by dou x square equal to 0. Generally, heat equation is this one. For steady state, this one. So remember that. And we have x equal to 0. What is this? X means x is the displacement, the distance. X is equal to 0 and x is equal to L. X is equal to L. Here L is 100. This is equal to 100. Okay. And the temperature change from U from 0 to 100. Okay. So I'm going to write the boundary condition. The boundary conditions are, therefore, boundary conditions. That means we can write dou u by dou x. Dou u by dou x at x equal to 0. Displacement is equal to 0 and any time t. So you can write like at 0 t. Any time t. So what is the temperature? U is the temperature, x is the distance. So the variation of the temperature at an initial state is 0. And also at the end, dou u by dou x at the other end, LT. That is the distance x and time t. This is also equal to 0 for every t. This is the boundary conditions we can get from the question. Starting position, that is variation of temperature at the initial position. Displacement is a distance 0 and any time t, that is equal to 0. And here the change of variation of temperature at x is equal to L. The other end that is also equal to 0 for every t. Okay, so these are the boundary conditions we can get from the question. And you have to find f of x. F of x means what we have to find out? Ux0. Always we are just considering this Ux0 that we are considering as f of x. Okay, we have to find that one. So in order to find that, we are going to use this one. They are given that initially it is in the steady state condition. So initially it is in the steady state condition means we are going to find this f of x or ux0 using this equation. Dou square u by dou x square equals to 0. Okay. So how can you find that u from that one? Let me write it here. So we have dou square u by dou x square. This is equal to 0. Because it is given that is the bar is in the steady state condition. So integrating this one, you will get it as u is equal dou u by dou x. Dou u by dou x. What is dou u by dou x? You will get it as dA. Okay. One more time you have to integrate. Then you will get u. So u is equal to, one more time you have to integrate means ax plus b. Kx plus b. Okay. Kx plus b. Now we are going to find this ux0 from that. So when u equal to 0, when x equal to 0, what happens to u? U is also 0. So I'm going to write that. So 0 is equal to x is 0. So this is equal to ax. So b is equal to 0. B is equal to 0 because when x is 0, u is 0. So 0 is equal to x is 0. That will gives you b is equal to 0. Let me write that. So 0 is equal to a into 0 plus b. So that gives you b is equal to 0. Okay, now we have to find the value of A also. Then you can write that. So, next condition is when U equal to 100, it says 0 degree to 100 degree centigrade, right? 0 degree centigrade to 100 degree centigrade. So, when U is equal to 100 for X is equal to L. At the other end, X is equal to L, U equal to 100. So it varies from 0 to 100 degree, 0 degree to 100 degree. And from 0 to L. What is our L? L is 100 centimeter long. I have given in the textbook. In the question, I'm sorry. It is given in the question. L is 100. So I'm going to do that also. So U is 100. So 100. This is equal to A into L is A into L. AX. U is equal to 100 is equal to A into L. A into L and B is 0. And what is our L? L is 100. So this implies 100 is equal to 100A and A is equal to 1. A is equal to 1. Okay. So we can write that U x0 is equal to U x0 is equal to. So we are finding this U x0 is equal to AX 1x plus 0. That is X. Ux 0 equal to X. So from that steady state temperature, they are given that. So from that steady state equation, we are finding U using the given condition. Using the given condition, and we are finding Ux 0 equal to X. So this is our f of x. This is our f of x. Okay. Now we are going to use all these conditions we have in order to solve that. So from where we have to start? So this is from 0 less than x less than l. In between this 0 and 100, we are using this. Okay, 0 less than x less than l. Now we use this steady state in order to find Ux0. We use this steady state equation in order to find Ux0 using this condition. Okay. Now we are starting our usual procedure. What is our usual procedure? We have to write the equation. Therefore, the equation, the heat equation. Heat equation is dou U by dou T. This is equal to C square dou square U by dou X square. Now what we have to do? We have to write the solution. What is the solution for heat equation? Once you got that K is equal to P square and everything, the final solution will be this one. So you must by heart this one also. UXT, the solution. The solution is, this is for the heat equation. The other one is wave equation. C1 cos Px plus C2 sin Px into e raised to minus C square P square T. You have one C3 also here in that solution TV, but we are not taking this C3 because we are in the final step we are equating all the constants to Bn or An, something like that. Okay, so you don't want to worry about this constant because we are equating the whole constant to An in the final step. So even though you wrote it here or you skipped it, that will gives you the same answer, same effect. So don't worry about that constant. You will get the same answer or the effect is the same. Okay, now what we have to do, we are going to use each condition. Okay, so put this as first equation. What is our aim? Our aim is to find C1, C2, the values and all. Okay, so here we have, which are the conditions that we have here? Dou U by dou X. Dou U by dou X at 0 T is equal to 0. That is one condition. Now the other one is dou U by dou X at LT. LT, this is equal to 0. This is the condition we already got, and we have this ux0 is equal to x. That we already find it out. So these three conditions we are going to use here and find values of C1, C2, etc. Okay. Now, in order to find this one, you have to find dou u by dou x. In order to use these conditions, you have to find dou u by dou x here. So I'm going to find dou u by dou x. Dou u by dou x is equal to, with respect to x, so minus C1 sin px into p sin px plus C2 p cos px and this is with respect to t, so it remains as a constant c square p square t. Okay, c square p square t. Now, in order to use this condition, you have to put x is equal to 0. In order to use this condition, that is our initial condition. So dou u by dou x at x is equal to 0. That gives you x is equal to 0 means this becomes 0. Sin 0, 0. So C2 p cos px e raised to minus c square p square t. P square t. So now what we have to do, you have to find the value of C2 or P anything. So from here, this is equal to 0. We already know that. We are using the condition, the boundary condition. This is boundary condition. So using this one, this is equal to 0. So if P cannot be equal to 0 anywhere. P cannot be equal to 0 anywhere. And this one not equal to 0. The only possibility is C2 can be equal to 0. If this is equal to 0 means UXT will be everything will be equal to 0. And that will be becomes a trivial solution. Trivial solution means this is equal to 0, meaningless. Okay. And if cos px, the whole thing, if cos px is equal to 0 or p equal to 0 means this is also not possible. This is also not possible. So the only possibility is C2 is equal to 0. Therefore, C2 is equal to 0. Now, once you got C2 equal to 0, you can write this dou u by dou x. We are going to write this dou u by dou x as, once you got that, we are going to write dou u by dou x is equal to minus dou u by dou x is equal to minus C1 p sin px into e raised to minus c square p square t. Because you are going to use this again one more time. Okay. So once you got C2 equal to 0, we are just writing dou u by dou x is equal to minus C1 p sin px e raised to, this is 0. C2 equal to 0. E raised to this one. So once you got this one, we are again going to use this condition. That is x is equal to L. X is equal to L, what happens? Dou u by, we have this dou u by dou x here. At x is equal to L t. This is equal to minus C1. X is equal to L. Sin P L sin PL e raised to minus c square p square t square. C square p square, t square is not there. T. C square p square t. Okay. Now from this one, C1 cannot be 0. C1 cannot be 0 and P cannot be 0. The only possibility is sin PL is equal to 0. Sin PL is equal to 0. That means the procedure for this also they kind of say PL is equal to n pi and L is equal, P is equal to n pi by L. So once you got that, you can write this UXT again. So we used those two conditions and we are going to rewrite this UXT again. So UXT is equal to, let me write it here. So our new UXT is equal to, C1, C2 is 0. So that is cos n pi x by L, n pi x by L, e raised to minus c square n square. I'll explain that, pi square by L square t. So once you got this one, C2 is 0. C2 is 0 and you got the value P equal to N pi by L using the second condition. So first, from the first condition, you got C2 equal to 0. So this becomes 0. And from the second condition, you got P is equal to N pi by L. So our new uxt becomes C1 cos N pi x by L e raised to minus c square n p. This is 0. P is n pi by x. N pi by L. So n square pi square by L square t. So that is our new uxt. So for this one, you can write the most general solution. We are going to write C1 is here. So general solution, we are going to write this as uxt is equal to integral sigma n equal to 0 to infinity an cos and one more thing I forgot that. Most general solution this one. So at t equal to 0, what happens? Before that you can write this. Okay, so let me write this first. Uxt is equal to sigma n equal to 0 to infinity an. For this one we are writing general solution cos n pi x by L e minus c square n square pi square by L square t. Okay, so this is our general solution. Now look at this one, general solution. Look at this one. If n equal to 0, what happens? If n equal to 0, what happens? N equal to 0 means this becomes 1 and this becomes 1 and remaining part is only a naught. Remaining part is only a naught. We are only getting a naught. So I am going to separate that. This is equal to a naught. I am taking it separately for n equal to 0. For n equal to 0, do you understand that? N equal to 0 means this becomes cos 0, 1. And here also n equal to 0 means the whole thing becomes 1. Whole thing becomes 1. Okay, so that means the remaining term is only a naught. That is why I am just separating this a naught. Next is sigma n equal to 1 to infinity an. So we are starting from 1 here. A naught we already took it here and n equal to 1. We are starting from n equal to 1 an cos n pi x by L e raised to minus c square n square pi square by L square t. Okay, so this is our uxt. This is our uxt. Now we have to find a naught and an. A naught and an. And for that, what is our formula for this? Is our half range cosine series. A naught and an are coming in the half range cosine series. And what is the formula for that? Anybody knows that? Half range cosine Fourier series. Half range cosine Fourier series. Half range cosine Fourier series. Formula. We need to find a naught and an. What is a naught? 2 by L into integral 0 to L f of x dx. This is our a naught formula for an. 2 by L integral 0 to L f of x cos n pi x L dx. This is the two formulas. So we need to use this formula in order to find a naught and an. Okay. So for that you want this f of x. Which is our f of x? F of x is, we already find it as ux0 is equal to x in between integral 0 less than x less than f. ux0 equal to x. Okay. So in order to use this f of x, this is the condition at t equal to 0. This is the condition at t equal to 0. So in order to compare or in order to equate these two, you have to find ux0 first. ux0 first. Then only you can take this f of x for this part. The condition must be the same. So I'm going to find ux0 for this part. Okay. Let me do that. So ux0, this is our uxt here. This is the final step we are getting. So at t equal to 0, what happens? ux0. ux0 is equal to a naught will stays the same plus sigma n equal to 1 to infinity an cos n pi x by L. And this part, what happens to this part? At t equal to 0. T equal to 0, what happens to this part? Anywhere else t is coming. Only this part t is coming here only. So at t equal to 0 means the whole thing becomes 1. The whole thing becomes 1. So this will reduce to a naught plus sigma n equal to 1 to infinity an cos n pi x into 1. And our ux0, the condition is ux0 equal to x and for 0 less than x less than L. Now this is fine. We can use this f of x in order to find a naught and a. So how can you find that? We can find that using a naught. A naught is equal to 2 by L. Integral, the length is from 0 to L. Okay. F of x is x. This is our f of x. This is our f of x. F of x dx. How can you integrate that? 2 by L, x square by 2, 2 and 2 will cancel out. Take the limit, you will get it as L square by 2, L square by L, L square by L minus 0. So this becomes 1 by L. This is equal to L. So A naught you already got. Now for An, what you have to do? So in order to use this as f of x, you have to rewrite your uxt into ux0. This must be the same. Then only you can use that f of x for this part. In the earlier problem also, we did the same thing. Okay, this must be equal. Then only you can use this f of x for this finding this a naught and a. So this is equal to 2 by L into integral 0 to L. F of x is x. And what is the formula? F of x cos n pi x by L. So cos n pi x by L dx. Okay. Now this part we can integrate and find the answer. You can integrate and find the answer. So once you got that, you can write the. Once you got that an, you can write your final answer. So an I'm getting as 2L, everything in your notebook. Okay. So this one part I think I didn't write that part in your notebook. So you must be you can note it down. At t equal to 0, ux0, I just put like the same thing, but this is equal to 1. This is 1. At t equal to 0, this is 1. That part is 1. All the other steps are okay. So an is equal to, this is the answer we are getting. Minus 1 to the power n, minus 1 divided by, that's it. Minus 1 to the power n. Okay, now n is equal to even means this becomes 0. So an is equal to 0 for n is even. An is equal to 0 for n is even. Now you can find A1, A2, A3, etc. And the final answer is, this is our final UXT, right? This one is our final UXT. Final step. We got like this. So I'm going to substitute in that. So that is equal to, UXT is equal to, what is our A naught? A naught is L. A naught is L and we are getting like L 2 by L is there also. Okay, so this 2 by L. 2 by L. The answer is A0 by L. Is like we are getting as L by 2. A0 by 2. So the formula is f of x is equal to, the formula is A0 by 2 plus, once you got A0 and AN like this is a formula. Sigma n equal to 1 to infinity AN cos n pi x by L. This is the final the formula. Once you got this one, A0 and AN, what is our half range cosine series formula is A0 by 2 plus sigma n equal to 1 to infinity AN cos n x by L. So these formulas you need to be thorough with. Okay. Formula for finding A0, formula for finding AN, formula for finding Bn. After that, the final answer, the final Fourier series will be in this form. F of x is equal to A0 by 2 plus sigma n equal to 1 to infinity AN cos n by x by L. So we are going to write that we got A0 as L. So L by 2 plus, L by 2 plus. You have to write as each term, or you can write it like this. Sigma, this is the final answer. N equal to 1, 3. When n equal to 0, n is odd. So you can write 1, 3, 5, etc. This will be 2L minus 1 to the power n minus 1 divided by n square pi square cos n square pi square n square pi square cos n pi x by L, and we have this part also, e raised to minus c square n square pi square t by L square, t by L square, where L is 100, where L is equal to 100. So this is the final answer we are getting. Okay, so once you got this form, you have to find A0 and AN using the half range Fourier series. The formula is A0 equal to 2 by L integral 0 to L f of x dx, and AN is equal to 2 by L integral 0 to L f of x cos n x. In order to use that condition, that is f of x is equal to x, you have to make this as at t equal to 0. This will vanish as this will becomes 1. And after that, you can use this x, ux0. That is important. Let's 0. In order to this one, you have to match it. Then only you can use this as f of x. Okay. So after that, you can use that as f of x for finding A0 and AN. After finding A0 and AN, you have to write the series like this. This is the formula for the whole series. F of x is equal to A0 by 2. This is from a Fourier series. A0 by 2 plus this one. So that is why we are writing uxt is equal to L by 2 plus sigma. For even n is equal to 0. Even n. So n is 135. This will be the answer. So this is how you have to solve all these problems. And heat equation, wave equation, derivation, go through all these problems. You will definitely get one problem from each section. Wave equation, heat equation, that I am sure. Laplace is so Laplace, the solution is important. They don't ask much questions from the Laplace part. But I gave you one problem in your notebook. Go through that. And the solution for Laplace, let me go through that one more quickly. The Laplace solution. There is no derivation for Laplace part. Only the solution part is there. So the solution part is like this is the solution. First you have to write the Laplace. What is Laplace equation? Laplace equation is dou square I. This one is familiar for you. Dou square u by dou x square. Dou square u by dou x square plus dou square u by dou y square is equal to 0. This is the Laplace equation. So no derivation for this one. No derivation. But the solution is there. Solution of Laplace equation. Solution of Laplace equation, the same procedure we are using for this one also. Solution is u. Look at this one. U is a function of x and y. So you can write let small u is equal to xy. Xy, and you need dou square u by dou x square and this one. So dou u by dou x is equal to x dash y. Dou square u by dou x square is x double dash y. This one we need. Dou u by dou y is equal to xy dash. Dou square u by dou y square, this is equal to xy double dash. After getting these two, substitute here. So you will get it as x double dash y plus x y double dash. This is equal to 0. What is the next step? You have to bring the variables to each side. So this is equal to minus x y double dash. Bring this x to this part, x double dash by x. This is equal to minus y double dash by y. And this must be equal to the same constant. So this is equal to k. After that, we can equate that x double dash minus kx is equal to 0. That is one equation. And the other equation is minus y double dash minus y ky is equal to 0. Once you got this one, find the solution. M square minus k is equal to 0. M square minus k is equal to 0. Here minus m square, you can write this as plus. Both becomes plus. So m square plus k is equal to 0. And what is the next step? You have to go through the three cases. Case 1, k is positive and k is equal to p square. Second case, k is negative and k is equal to minus p square. And the third one is k is equal to 0. Go through all the cases, and for the Laplace equation, you can write the solution. It depends upon the problems. So you cannot say like this is a specific solution for Laplace equation. Just write all these up to this part. This is fine. Okay, they are not given the specific solution for Laplace equation. It depends upon the problems you got. So once you got a problem, you have to identify which formula you have to use. So you can finish. You can write up to this part. That is fine for the Laplace equation. Okay. Okay, and go through all those problems and all for this fourth module. Definitely you will get a problem from wave and heat. And the solution of Laplace equation is important. I think it's okay. We covered almost all the portions. And if you have any questions, you can ask me through WhatsApp and all. Questions will be from textbook itself. What do you mean by that, Shanida?
Ma'am, the model will be like the one given in textbooks, right? Not from outside the thing or anything.
I don't think so. They will ask from the textbook. Yeah, notebook is based on the textbook. Like, refer Graval textbook. I don't think they will ask any outside question or nothing. Anyway, you have the or also. For each question, you have the or portion also.
Okay.
So you don't want to worry about that. Go through that Graval text and learn thoroughly based on the notes I gave you. Not all of them in the Graval textbook. Based on the syllabus, you have to learn.
Okay. Yes, ma'am.
Yeah. Anything else? And if you have any questions, you can ask me through WhatsApp. Okay. So that's it. This is fine, right?
Yes, ma'am.
Yeah. So all the best for your exam.
Thank you, ma'am.
Okay. So that's it. And if you have any question, you can ask me through the WhatsApp privately, not put it in the group. Okay, then thank you. I'm leaving now.